Hello, everyone, and welcome to another episode of Learn with Jason. Today on the show, we've got Swizec Teller and his bird. I forgot to ask your bird's name.
So my bird's called Kiwi. Okay, he flies away, but he's usually okay with being on camera. He just sometimes gets shy.
Excellent.
Uh,
So, yeah, we'll see if he wants to join us a little bit later. Well, thank you so much for being on the show. To those of us who aren't familiar with your work, do you want to give us a little bit of background, who you are, what you work on, all those fun things?
yeah, so I'm Swiz. It's much easier to pronounce than my full name. I've been doing React data visualization for a couple of years now. I have a course out, reactforDataViz.com. It's actually launching with a couple of updates in about a week or two. But today I just wanted to, I've been really meaning to try data visualization with Gatsby because you know how a lot of data viz, when it comes out, it first has a loading screen and it's really annoying. And I think
Hmm.
Gatsby would be a great way to solve that so that you immediately see something cool. So that's what excites me about today. I want to really see if we can get this working and build something cool.
Yeah, I think that's going to be a lot of fun. So, with that being said, I guess we can just kind of jump into it.
Yeah.
So to start, I'll get us set up with a blank site. So let's do just the Hello World starter. Gatsby starter Hello World. Looks like
Oh
Mr.
wow.
Naim is familiar with your bird.
Yeah, it's he actually even shows up in a lot of my actual teaching videos because you can't
Mm,
get rid of him. So I just incorporate him instead.
perfect. All right. So that then puts us in the position where we should have a good, clean repo.
Hmm.
And all we have right now is an index.js. So nothing in our Gatsby config. Our
Hmm.
only dependencies are Gatsby React and React DOM. Um, we're ready to roll. How should
Awesome.
we get
So
moving?
we should start by installing D3. So yarn add D3 that should do the things.
Okay. Do
And
we
then
do?
yeah, add D3. I don't think we need anything else right now.
Okay.
So that installs the D3 library, which is the probably one of the most, if not the most popular libraries for data visualization on the web. And we're going to be using it to calculate, to kind of parse data, calculate data, make. We're going to work with random data today so that it's easier, right? Because we don't have to worry about data sets.
Yeah.
And we're going to be using D3 to calculate positions and then React for rendering an SVG.
Okay.
And I'm hoping that because Gatsby is awesome, is going to render the SVG at build time and then just show it up on the screen without actually loading any data or stuff. Because you
Cool.
can have 5 megs, 10 megs of data sometimes to parse and display a chart,
Mm-hmm.
and obviously we don't want users waiting for that, right?
Yeah. So the kind of our big question here is going to be whether or not D3 relies on the window object or any other browser only APIs. If it does, we would be in the same position that you'd be with anywhere else. We'll have to ignore it during the build phase and
Yeah,
then render it on the client side. But hopefully that's not the case and we'll be able to do it during the build.
exactly. I don't think
Ecomath,
there's
those are
anything.
indeed birds in the background. We've got Kiwi joining us as
Yeah,
a special guest.
yeah, yeah. He's gonna come to my shoulder eventually, I hope. Um, cool. So let's go into index.js
Okay.
and start by, I guess, importing
Holy
asterisk
buckets.
from
Did that just
D3
work?
so we have the whole library.
So I just call that like D3.
Yeah, as D3 from D3.
Okay.
That's just the. It does have code splitting and everything, and it's actually a bunch of different libraries under the hood, but it's easiest to import everything and then let Webpack deal with that and make your bundle small.
Okay, cool.
Cool. So then we're gonna have to, let's start by creating some random data. Um, I guess an example I always like to use is to start with a scatter plot. So we just need two-dimensional random data. Let's say 20 data points to start with. So you can do d3.range 20.
D3 dot range 20.
Yep. So that gives you an empty array of 20 elements.
Okay.
So you can map over that. Map, and we don't really need the argument, so you can do underscore and then just return a array of two random numbers.
Okay. And should we like try to get these in? Because if I just do math random, that's going to give us like 0 to 1. Should I try to set these to be something else? Or
I'll show you how to do that with D3. So you can, yeah. A cool thing with D3 is that you try to let your data be raw, and then as you're rendering it, you make the transformations.
Okay.
So you can just do math.random.
All right.
And we're doing it's an array of two numbers because that's going to be our two dimensions, x and y.
Right. And so this is like my X and this is my Y.
Yeah, exactly.
All right. Do we need
You
anything
can
else in
also
here?
do it as an object if that makes more sense.
I mean, I'm happy to do it either way. Is there a way that's going to be easier for kind of parsing?
Actually, yeah, let's do it as an object x and y, because that way the code is going to be easier to read for everyone.
Okay.
Hi, Bert. See? It's right there. Cool. So that gives us the data.
Okay.
We can go into the index function and let's instantiate the data in so just const data equals get random data, and then we're going to use D3 scales to translate between those 0 to 1 numbers and going up to whatever we want the width and height of our visualization to be. So we're going to create a x scale, const x scale, and we're going to make it a linear scale, and I'll explain what that is in just a bit. So it's d3.scale linear. Let me turn off Slack so it's not making noise. Scale linear, and that's just a function call.
Okay.
So you can think of D3 scales, especially linear scales, as a scale as a function that you learned about in like probably middle school. It's basically x equals kn plus no, y equals, fuck it, now I don't remember.
That's how I feel about math pretty much every day.
Yeah. But basically, it's just a function that translates from a domain to a range. So if we tell it our numbers go from 0 to 1, map those to numbers from 0 to 100, it's going to automatically figure it out for us. It's basically, it creates a function that's going to be called on each item of our array and do the translation. So we can say scale linear, then dot domain to define the domain.
Scale linear dot domain.
So scale linear, that's a function that creates a function. Keep it a function called dot domain, yeah.
Okay.
And then inside the domain, enter a 2-element array that says so array 0 to 1.
Okay.
Yeah, and that's kind of the pattern that a lot of D3 uses, is that it uses these because it's kind of an oldish library from before we had classes and objects and stuff. So it kind of internally using class generators. So you can think of this scale linear as creating a function that has its own closure that then exports getters and setters that you can call into the function.
Okay. All right.
So domain is a getter. It's both a getter and a setter that lets us set the domain.
All right. And so we're setting it right now to say that the numbers that we're going to provide are between 0 and 1.
Exactly.
Okay.
And then we can say dot range goes from 0 to, let's say, 100.
0 to
and that's
100.
going to be our the size of our graph, essentially.
Okay.
See, as that zeros are going to map to pixel 0, ones are going to map to pixel 100, and everything in between D3 is going to just figure out for us.
That's handy.
Yeah. Now, then you can do the same for the Y scale. And So just copy paste this and call it a Y scale instead of the X scale.
Okay.
And I like this pattern, even though they're the same scale right now. In the real world, you often have different proportions and different dimensions when you're doing horizontal and vertical
Yeah,
coordinates.
if
So
we were
it's,
doing like percentage on one scale and like audio or
yeah, exactly.
years through another scale or something. Yeah.
Yeah. So it's always useful to have two scales. You also might not always want to have a square graph. Cool. So, hi, Bert. So now let's make this return an SVG.
Okay. Oh boy, this is going to be
Then,
fun. SVG.
yeah, SVG. And then uh, let's give it a width of 100 and a height of 100.
100, height of 100. Yeah, I think the audio is, I
Okay, the
think,
audio, I should probably just not move in and out of the mic. It's probably the problem.
just don't move your head for the rest of this
Yeah,
episode.
exactly. I'm just going to move here, and I think this is going to be better. All
Okay.
right. So inside the SVG, let's look over our data or map over our data.
Okay. Data.map. And then while we're doing that, I'm going to set up the SVG over here. Okay.
Yeah, perfect. Data.map, and we get in the let's usually you call it D for just the data item,
Okay.
and that is going to return a circle.
Returns.
So
Oh,
at
sorry.
SVG has an
I'm moving
element called
your,
circle, so you can just write it
you
as circle.
write it as circle,
Yeah,
circle.
like that. Yep. And let's say CX. So for the circle, you position it with the center X and center Y attributes. So you say CX equals, and you pass in, you call X scale with the argument of D dot X.
Oh, okay. And then
So
same
we're
thing for
taking
CY.
the, yeah, and then the same for Y. So
Okay.
CY equals Y scale of D dot Y.
Okay. And so to just repeat this back and make sure that I understand it, is it self-closing like this?
Mm-hmm.
Okay. So I'm going to save this so it formats for us. And if I understand this correctly, what we're doing is we're saying for each data point, we're going to create a circle on our graph
Yep.
that has the positioning of our random number as applied to the 0 to 100 scale.
Yep.
Awesome. Okay. All right.
Cool.
That so far so good. I understand everything that's happened, and this is great because we're already really deep into areas that I never go.
Awesome. One thing we got to make sure is that the circle has a radius,
Okay.
because otherwise it's going to be invisible.
Okay.
So let's give it a radius of 5. R equals 5.
Oh,
It's
R
just
equals
R.
5. Got it.
Yeah.
Okay.
I think, yeah, SVG was invented before they thought of long attributes and typing. So I think
Okay.
this should already render a simple scatter plot for us.
Okay. In that case, let's see. Export default. Let's get this thing running and see what happens.
Mm-hmm.
So we've got Gatsby building. All right.
Yay! That's awesome. So we can make it a little bit bigger. I think that's kind of small.
Okay.
So you just adjust the range of your scales to be, say, 400. It's going to make it bigger.
And so if I like make these 400, I need to change these as well.
Yes, that's true. So it might make sense to change that into width and height variables, constants.
Okay.
Nice.
Yeah, let's do that. So we'll do const width and we'll set it to 400.
Mm-hmm.
And then we'll do the same thing for height. And then we can change out, let's see, X is width.
Yep.
Ooh, all right. Glad I got that on the right first try. And Y is height.
Nice.
Okay.
Cool.
Oh,
We can
thanks for
also make it
the subscriptions, Pansock and Mortal Draw. That is awesome.
nice.
Okay, so now we have a 400 by 400 scatter plot,
Yep.
and it's drawing our random data. So every time we refresh, the data moves around. So this is super cool. And I guess the next thing, if I'm maybe I'm not jumping ahead here, we need to add like our axes, right?
Yes, let's do that. So
Okay.
for the axes, we're going to use something called a black box rendering method. So we're going to, how do I do that? It's been a while since I did that. Let's install my D3 black box library. That's going to make it easier.
Okay. Is it just called D3-Blackbox?
It's D3 black box without the dash.
Blackbox, like this?
Yeah, D3 black box.
Perfect.
Okay, and the idea with black box rendering is that we're going to render a SVG node with React, and then D3 is going to take over the inside of it and do the rendering itself. The reason we're doing that for axes is because D3 comes with pre-built axis generators, and axes are annoying to build yourself, so it's easier to just let D3 handle that.
Okay.
It's not quite as performant as if you were doing it with React, because the diffing algorithm goes away, because that's why I call it a black box, because React can't see inside. But it's just so much easier, and for small components like axes, it totally makes sense.
Sure. Yeah, that does totally make sense. So I assume I need to import that then.
Yes, import use D3 from D3 black box.
Is
I
that a
think
named import?
I think it's a named import, yes. Let me double check. Is it a named import?
Ooh, solid Zoolander drop. It was indeed a scatter plot for ants. It is no longer a scatter plot for ants.
Cool. Yeah, it was a named import.
Okay.
So we've got that. Now let's make an axis component.
An axis component. Okay. So we'll
So it's
go
going to be
const
just a normal
axis.
functional component.
Okay.
And we're going to pass in a, let's say, an X, a Y, and the scale.
Like so.
Yeah, X, Y, and scale.
Okay.
Now, let me see if I still remember how to use this. Okay, so we're going to use the use D3 hook. So we're going to say const ref equals use D3.
Like that.
So the way this works is that in D3 is going to take a function as an argument, and that function is going to do D3 rendering. It's going to get the anchor element, and then it returns a ref so that we can render the anchor element and give it a ref, so that it's going to make more sense when we actually do it. So
Okay.
use D3.
Okay.
Inside, let's make a function that takes the, let's say, element.
Inside here.
Yeah, let's say EL or
EL.
element, whatever makes it easier.
We'll go EL. We're doing short form variables today. This is going to be
nice. Okay, so for EL, now let me just see how axes actually work. We're going to run a D3 select, D3.select of the element.
Of the element.
Mm-hmm.
Okay.
I'm just looking up D3 documentation because I always forget how to make axes. So D3 select it makes a D3 selection out of any DOM node.
Okay.
And it's basically like, if you remember from the olden days when we used to have jQuery,
Yeah, I do.
is similar to calling dollar and then giving it a either directly an element or something.
I got you. Okay.
So, okay. And then we're going to say .call.
Call.
Yeah. And inside .call, we're going to pass in an axis called d3.axisLeft.
Axis
I'll
left.
explain, yeah, axis left, and pass in the scale as an argument.
Scale. Okay.
Cool. So what's happening here is that D3 axis left is a axis generator that comes with all of its own calculations and rendering stuff. We're
Okay.
calling that on the D3 selection so that it's essentially rendering the scale into that element. And use D3 is handling a bunch of stuff behind the scenes to make that actually work.
Gotcha. Okay, cool. Very cool.
So now what our axis component needs to do is return a grouping element. So return G.
G.
Yeah. Return G, and G is going to take a transform attribute.
Okay.
Transform, which is going to take a string called translate XY. And I'll also
Translate
explain what that does.
XY like this.
So it needs to be a ES6 string. Think of translate as a function. So you're calling the translate transformation function with X and Y. Yeah.
So template ES6 string like
yes,
this.
Right, translate.
Translate. Oh, and then like X.
And then with a, put it in parentheses.
Like this? Oops.
Yeah.
Here.
And like that, yes.
Aha.
So what this is doing is, with SVG, you can position and transform elements. There's a bunch of different transformations. You're taking the grouping element, which is like a div in SVG, except it doesn't come with any preconceived notions of how it's supposed to be rendered. Then you're passing in a translation, which is taking it's basically moving your element by the XY vector. So it's positioning it at XY, but it's called a translation because you could then have rotations and scales and a bunch of different things.
Okay. Cool. Do we put anything inside of this? Or are there any other attributes on it?
Pass in the ref. So the grouping element itself is going to be empty, but it takes our ref as the argument as well.
Okay. All right. So now we have created a group. It's self-closing. We added the ref that we created with use D3. And then we're going to translate it to an XY value that we are going to send in via props. And the ref sets up our left-hand axis.
Yes.
Okay. Do we need to set up a similar thing for the, I would assume, axis bottom?
So we're going to keep this the same. Let's just try if it actually works first.
Okay. All right. So I have an axis. Do I just toss this down at the bottom here?
Yeah. Just toss it down at the bottom.
Okay.
And pass in, let's give it some padding on the left so it has room. Let's say render it at 20. Horizontal. Yeah. And then vertically at 0.
Okay.
And you pass in the scale is going to be Y scale.
Y scale. Okay. So save that. Let's see, we're already running, so it should just work. Okay, so that's pretty close. Let's move it over a tad bit more. Maybe 40.
40, and I think it needs some padding on top as well.
Okay. Let's
top
go.
And bottom, but instead of doing it here, let's keep.
Oh, instead of doing it here. Oh no.
So go to change Y to. No, actually, don't change Y. Go to the scale, the Y scale.
Okay.
And change the range to go from 5 to height -5.
5 to height -5. Okay, that helped.
And now the scale, see the axis automatically adapts to the scale, and so does the scatter plot itself.
Cool.
So another thing we can do is go into the X scale and set the starting position at 45.
Here.
Yeah. And that will make it so that nothing is overwriting our
Ah,
axis.
nice. Okay.
Automatically
And
moves
so
over.
now we can get it like right up on there, but no matter what we do, it's not going to end up on top of the axis.
Exactly.
All right, I'm into that.
And the reason axes take the scale is so that they can automatically adapt to that, but they
Holy
also
buckets, did that just work?
automatically change the labeling and figure out how many labels there should be and stuff like that.
Yeah, yeah. So this is really cool. I do notice we start at 0 and go to 1.
Mm-hmm.
And so I have two questions about that. The first one is this is kind of upside down from what I would usually like the way I would typically think a data viz. And then the
Yep.
other one is we set the scale to like 400 or so.
Yep.
And does that mean now I maybe I misunderstood what we were doing, but I thought that we were setting this up to be 0 to 400. Wait, I think I just realized something. What the
Yeah.
scale did, it didn't change the values. It mapped the values to the right pixel distances to match our scale.
Exactly.
I understand. Okay, so my mental
The,
model was broken.
so the data is still going from 0 to 1, but we're rendering it from 0 to 400.
Gotcha. Gotcha. Okay,
Uh,
I understand.
yeah, and that's why I like using scales, because you're not messing with the actual data, which means you can always know what you're actually rendering. Um, so if you go into, so right, for inverting the thing, one of the annoying parts of SVG is that 0, 0 is at the top
Mm-hmm.
and Y gets bigger as you go lower down.
Mm-hmm.
It makes sense. I don't know why graphics people do it that way. I think there's some logic where it makes sense.
Mm-hmm.
So what we can do on the Y scale is invert the range. So it goes from height -5 to 5. And in theory, that should automatically flip it.
Nice. Okay, cool.
Yep. So now it's going from bottom up. Now let's add the bottom scale.
Okay. And can we do this in the same axis or do we have to create a second one?
We can do it in the same axis. Let's pass in an argument for scale type, for axis type. Yep.
Okay.
Instead of calling d3.axisLeft, we can do a dirty old school JavaScript trick and use it as if it was an object with keys. So we can construct the axis left, axis bottom, axis right by saying by using it as a string and then adding the type to it. Or
So
that works as well.
so well yeah, so I'm basically thinking like okay, so if it's the y axis, we'll go axis left or it will be is it
Yep.
axis bottom?
Axis bottom, yeah. That
Okay.
totally works. There's
And
also
so
top and right. So I usually try to just do it there.
this we're basically what we're doing is if
Yeah.
do you have a preferred way of doing this? Like should I call it left or
I think it's easier if you call it left. That way it's consistent with the D3 API. So other
gotcha.
people using it after us don't get as confused.
Okay, cool. And so this is kind of a we're adding some assumed knowledge here. Like you have to know
Yes.
when you use this axis component that you can either choose left or bottom. If we were designing a more robust component, we'd probably have like an enum and things like that. But let's, for now, I guess we can just say axis type is left. And then if we add another one, we can say bottom. And then we'd add the X scale.
Yeah. You
And then
add the X and you have to change where it's rendering. That 40 is good, I think.
Okay.
Y should be at height minus, let's say 40, so it has the same kind of padding.
Okay. Close.
Okay,
Not
so
quite
it needs to
there.
be rendered at 0, not at 40, because the X scale itself already takes care of the padding. So for the X argument.
Okay. And then we need, let's,
And then for the Y scale, we need to add that same 40 padding as we did on the X scale. Yeah, because
we,
if you render it at 0, it's going to be invisible.
oh, I understand. So we're doing width minus, hold on,
So
40.
X scale goes from 45 to the full width. Y scale is now going over our bottom scale. So it needs to go from height minus 5 to 45 instead of 5. And that should move everything up a bit. The other way around. It needs to go from height minus 45 to 5.
Got it. Okay. All right. This is like this kind of math is like my brain is like rebelling against this.
Yeah. Yeah, I feel yeah. So we now
Okay.
have a scatter plot with axes.
Yeah, this is awesome. Okay, so this is really cool. So we've got a scatter plot, we've got axes, we've got the scale working. Is this cut off?
Yeah, that's cut off because it's going right to the edge of our SVG.
Okay, so we need to set the width minus 5,
Yeah.
width minus 10. There we go. Okay, so we have a scatter plot. Things don't get cut off. We've got axes. So this is pretty powerful stuff. So now, should we just try building this and see if it explodes?
Yeah, let's try it.
All right. So what I'm going to do then is I'm going to stop this. I'm going to run yarn build, and we're going to find out if D3 relies on browser APIs.
Nice.
Okay. So far, so good. No immediate destruction.
Mm-hmm.
Okay.
Yeah, everyone in the chat is saying that D3 is confusing.
Yeah, the X and Y scales are hard. Like, I mean, this is all kind of, what would you even, this is like linear algebra, right? Is what we're doing right now?
Yeah, this is like the very basics of linear algebra, I would say. It can get a lot more complicated. Um, actually, yeah, this is just linear functions right now. So it's not that hard.
Yeah, I think the thing that's hard is like for me, for example, I just don't ever do any
Yeah,
math like this. And so
yeah, I think that's the thing. It's like if you haven't done high school math in a while, this can be really weird.
okay.
It's
So
better.
this is what gets rendered without JavaScript.
Interesting.
And so I think the reason that it's working for the scatter plot but not for the axis is that
Hmm.
my guess is that Blackbox is doing something magic
Yeah,
that doesn't get picked up during the render. So to do a full server side render, we'd probably have to manually do whatever work is happening inside the black box to render those
yeah, I think
SVGs in
so.
React.
Yeah, because right now it's essentially injecting D3 rendering into that React component. And then because it's not React rendering that, you don't get server-side rendering.
Mm-hmm.
But this is still better than just looking at the loading screen.
Yeah, I mean, this is really cool that this is it's just kind of like functioning for us, which is great.
Yeah.
Because we're generating random data, this is going to get really weird because if we were to
Oh,
show
yeah.
it like, we would see this is what got server side rendered, but our data would all change as soon as we rehydrated in React, which is, I mean, that's fine. It's for a demo, but the proof of concept here is strong. Like we've successfully server side rendered D3 in React. There are a couple things we need to work out, which we can, like, if you want to, we can dig into that now and do axes the hard way.
Let's do it.
All right, let me turn JavaScript back on for a bit. Let's Oh, come on. Oh boy. Working on this small browser makes it really hard when I have to turn things on and off and like find settings and
Yeah,
such.
bad.
All right, so let's refresh. All right, here we go. So JavaScript is back on. We're
Uh-huh.
in good shape.
Did the data change?
Um,
I can't tell if it jumped or not.
oh, the reason. Okay, so here's why it didn't change. Because we are using rendered data, Gatsby is pulling the data and like caching it as a JSON object. So it looks like it is. Oh yeah, see, because the data
Right,
never
because
even.
because we're not generating the data in the renderer, we're generating it outside in the page itself.
Yeah, so it looks like Gatsby actually does cache that, which is kind of cool. I wonder if that would bite us in the ass if we were trying to do live updated data or something.
Uh, let's try something. Can you go back into the editor
Mm-hmm.
and move? Actually, no, because we are calling get random data inside the rendering. I thought if we move get random data here, then it wouldn't,
Mm-hmm.
but we are calling it on render. We're not calling it outside.
Mm-hmm.
That's that's magic.
Yeah, I think so. The way that Gatsby handles a lot of this stuff is it pulls in this page data, and I
Hmm.
think like one of these is going to have, I'm not sure which one, component source page index. It's going to have like all of this data probably hard coded because it'll have done that work ahead
Right.
of time.
Is
I
it
don't know where. No, this is.
so that's what it's doing with GraphQL as well, I guess. Is it instead of so
Mm-hmm.
it doesn't have to run the queries every time you load the page, it's doing it at build time and then hard coding it.
Exactly. Yeah. So it's we actually lift the queries entirely out of Gatsby. So like when you run GraphQL during the build, we
Hmm.
use Babel to like just parse the AST, find the GraphQL queries, lift them out entirely, replace them with the JSON data, and
Wow.
then rebuild that file. So that's kind of how we let that work.
Nice. That's amazing. I'm really surprised that it works with random data generated in a loop as well.
Yeah, this part seems like something that has the potential to be a problem. I don't know. I'd have to ask somebody on the core team what's happening and why that's so stable. Because it
Yeah.
seems like even with the server side rendering, that random math should still continue to do random math.
Randomness. Yeah.
But yeah, I'm not sure.
I
But I
mean, I
mean,
guess in real life you wouldn't usually be using random data.
right? Yeah, there is. It is just sitting in the cache. The confusing part is how that's cached, because it's a random. Like I didn't realize the Gatsby was going to find something like that and convert it to static data. It seems like that would be a potentially problematic thing to do. But maybe that's like a protection against using math random in your React keys or something like that.
Oh, maybe.
But who knows? But either way, now that we're using develop again, we're getting random data.
Yeah.
So I guess the next, what do you want to do next? We could do different types of visualization. We could try to get these axes working.
Um, I'm kind of scared of trying to do the axes ourselves because
I
that could get messy.
I am totally comfortable with that because I feel like just doing the little bit of SVG we've already done is frightening me. So,
Yeah. Um, let's try. What should we try? We could try making maybe animating this.
ooh, okay, yeah, let's do that.
Okay, let's try animating it. So let's. Oh, actually, I have a really cool example that I like to show people. You can
Mhm.
use this scatter plot as a data point in another scatter plot. So you have a scatter plot of scatter plots.
What?
Yeah, that it always looks cool. It's completely useless, but it's super fun. Let's try that.
All right, yeah, let's do it.
Okay, so let's go into the editor,
Okay.
and instead of rendering a circle, let's render something called a data point.
Like
And we're
this?
going, yeah. So we can keep everything else the same, I think.
So just straight up do that.
Yeah, just rename perfect. Now let's build the data point component.
Oh, like this is a component.
Yeah, so it's going to be a component.
Okay.
Got it. So we can make a data point component.
So that's going to get CX, CY, and what was the other thing? CX, CY, and
CXCY
R.
radius.
Okay.
All right.
We
Now
need to
let's
go deeper.
try. We can try copying the entire thing that we have here. So not that one, but the entire index function.
Oh, I see what you. So just take this whole thing.
Yeah.
Oh boy.
Let's do that. Now we're gonna have to change the width and height to be. Let's change them to radius.
Change these.
Yeah.
To just like straight up radius.
Instead of 400, it's just going to be R.
Oh, I see what you mean. Okay.
That way we don't have to change a lot of code. We just have one line that we change. And instead of rendering it with data point, let's change that back to circle.
Circle.
Down in the rendering here.
And then am I setting this to like CX and CY?
Yes.
Okay.
CXCY, and let's change. Actually, no, in here they should still be X scale and X stuff.
Okay.
So change that back. Radius, change it to, let's say, 1, so they're not too huge.
Okay.
For the circle. And instead of the SVG, let's render a grouping element. There.
Okay.
And the grouping element, we're going to use the translate transform pattern and pass in CX and CY.
Transform.
I think transform then translate.
Oh, yep, you're right. Let's see, we'll go transform, translate, and then CX, CY. And I don't want this width and height then.
No, you don't need them. I don't think they even do anything on a grouping element, to be honest.
Okay. Then we're creating our circles. We have an axis. How about this?
Let's change the paddings to 0.
0.
Because these are going to be pretty small. Or maybe we can even get rid of the axes because they probably won't really fit. But we can try.
Yeah, let's go chaos mode and find out what happens.
Nice.
Whoa. All right, that's wild.
Cool. And what else can we try? Let's give them. I think we forgot to pass in a radius.
I think we passed in a radius, but we didn't. We like kept some of the features here, like the 45 and stuff.
Let's change all of those back to 0. I think.
Okay.
It's going to be fast.
And then we'll go width. Change that one to 0.
0, and then go. Nice. Now go into the main scatter plot and give them a radius of, let's say, 40 or 50. So the data points are a bit bigger. Not that one, the other one. Here. So this is defining the size of the internal scatter plotter.
I get you. Yeah, so here we go. We've got our 40 or 50. So it's radius 50 now. And then we get a whole bunch of random data plots. Holy buckets. Did that just work? Oh, man.
See if we can change those data plots. How do we tell the axis to not render as many of them? I just need to look that up. Scale ticks. Okay, so if we can go into our axis component.
Okay.
And change. Let's pass in an argument called ticks.
Uh, Here,
Yeah.
ticks.
Yep. And that's basically going to be the number of ticks that we render on the scale.
Okay. Should we
The
set like a?
axis
Is there a
data. Yep.
reasonable default here?
Um, I think let's do 10.
Okay.
And when you're call D3 function name scale, do a dot ticks 10 ticks. So
Here.
one more to the right. So
Oh, after.
you're generating an axis, you're creating an axis generator based on the scale, and then again it has the
Gotcha.
accessor or getter setter, and you set the ticks. So in our data point scatter plots, we can say to just render 2 ticks. So here, when you have the axis, pass in ticks equals 2.
That's cool. Yeah. So this is like full chaos, but that is awesome. Like, and it's very cool to see how kind of flexible this is because that means, this is kind of an absurd example, but the
Mm-hmm.
power that this gives us is like we could render a tooltip, we could render a picture of my face, we could render like anything that we imagine as our data point.
Yep.
That's very cool. And obviously this stuff isn't like super accessible. It's all things you kind of have to know, but it's
Yeah.
not hard. It's just there's just some context there.
Yep.
But now that we've had our education from you, I think we all are ready to go do this professionally, right? How do you feel about that, chat? You gonna go do lots and lots of data viz?
I think the more usual use case for something like this is that you use this React and D3 approach to build a suite of components for data visualization. So you're going through this pane once, and then everyone on your team can just plop a scatter plot anywhere on your app that looks like it belongs to your app.
Mm-hmm.
Let's try something silly. Go into the data point component
Okay.
and add, after the translate, add a rotate 90.
Okay. Is it
There.
90 or 90 degrees?
It's 90.
Okay.
I think it's in degrees, not in radians. One of the confusing things with SVG is that some of the arguments use degrees, some use radians, and you kind of just
Oh.
have to try and guess. Um, it's amazing that way. But now they're all rotated.
Okay.
Um, Maybe do 45. I think that's going to look nicer. So let's try animating that. So we're going to have spinning. Let's make spinning scatter plots inside of this thing. So
Yes.
we're going to create a use state
Use
for
state.
our, yeah. So we're going to be using React hooks. So we're going to need use state and use effect.
Use effect.
Mm-hmm.
Got it. And are we doing this in data point or in the main?
Yeah, let's do it in data point.
Okay.
So the pattern we're going to be using is that we're going to be changing state every 60 times per second, and that's going to automatically create animation for us.
Okay.
So we're going to, let's say, degrees and set degrees.
And should I
And
like initialize it at 0 or something?
yeah, 0 makes sense.
Okay. And then we needed a use effect.
Mm-hmm.
And do we want this to update on anything or just like constantly?
Let's just on the empty array, so
Okay.
on mount. And we're going to, let's start first with, how should we do this? Oh, I know. Let's do a d3.select.
D3
And
dot select.
so we're going to start a d3 transition that is selecting nothing. So it's just giving us a space to start a transition.
Okay.
So d3.select.transition.
Dot transition.
That dot transition. I think it needs to have a name. So let's give it a some sort of unique name because they are all going to have their own transitions. So
Oh,
we need,
unique name. I get it. Okay.
yeah, needs to be
So
unique for every one of them. So
we can call it like, let's see, we're getting CXCYR. Let's just put all those numbers together, and that should be.
that should be unique enough.
We won't even need the R because that's the same for everything. Okay.
CXCY, not CXCX.
Oh, yep. Okay.
Transition, and then let me look something up. I'm just looking at one of my old articles because I often forget the exact sequence of arguments for this.
We were just Lori, who I believe is in the chat right now, was joking about this on Twitter earlier. How like as you get more experienced, you aren't really a better developer. You just have better notes to reference, so you can go back and read things that you've already written.
That's a good one. Okay, so the transition then dot tween, TWEE, yeah.
Okay.
Tween, and this is going to also have a name. This one doesn't have to be unique. So the first argument is just, let's say, spinning.
Okay.
So it's a string spinning. And the second argument is a function.
Okay. Does it take
and
any?
It doesn't take any arguments, but it returns essentially a parameterized. So basically, what we're doing here is defining a custom transition or a custom animation that takes as an argument a t parameter that goes from 0 to 1, basically the time of our transition.
Okay.
And we're telling it what to do on every time that this changes. So in our case, in what D3 expects is that we're going to be returning values, but what we're going to be doing instead is calling set degrees so that React is handling the rendering.
I understand. Oh, I also spelled this wrong.
So return t.
Return t.
T, and it's a function. So t fat arrow.
Oh, okay, I got you. T fat arrow.
Yeah. So it takes t as an argument, and we can say set degrees.
Why do I keep wanting to write digress?
Yeah. And now we need to translate. So it's easiest if we're going to use a D3 interpolator to do the heavy lifting for us.
Okay.
So we can do math.round.
Math.round.
Interpolate of t.
We're
going to call it interpolate.
Interpolate, but we haven't actually written this yet.
We haven't written it yet.
Okay.
We're going to, and that's going to take t. Now, right before that return, we can do it inside the tween is easiest. So go one there. Yes, we're going to say const interpolate equals d3.interpolate. So okay. This is very similar to a D3 scale, except it's a lower level API that scales used internally to figure out details. And we're going to say we're interpolating from 0 to, let's say, 360. So that's going to be a function there.
360.
0, 360.
Okay.
So this is D3 interpolate is creating a function, or you can think of it as a scale that maps numbers from 0 to 1 to numbers from 0 to 360. And parameter.
Yeah. So to just kind of visualize this again, when we created a scale for the y here, we have values between 0 and 1, but our graph is 400 pixels wide. So when we create that y scale, what we're saying is like 1 is actually 400 because we're mapping those scales.
Exactly.
Okay, and so we're just doing the same thing, but now we're doing it on a like 360 degree basis.
Yes.
Okay.
Exactly.
Okay.
And then the D3 transition is going to run, and it's going to call this tween function every time. And based on the t parameter, which is time, goes from 0 to 1, that time is going to then the interpolator is automatically going to calculate how much to change the angle of rotation so that the full animation fits into the duration that we're going to set.
Okay. Okay.
So we now add to the transition a dot duration.
Let's see,
You
transition
can
dot
chain it onto the
tween
tween at the
dot
end.
duration.
Yeah. Dot duration, and let's say 1 second, so 1000.
Okay.
And now we shouldn't, this should just work if we try it.
Okay, do I need to set, so I have the rotate here. Do I need to remove that?
Right, you need to use the degrees from our state.
Degrees. Okay.
Yep.
And so now to walk through this and make sure I understand, what we're saying is as soon as the component mounts, which is why we're adding an empty array to use effect, we want to use D3 to select nothing, just create like an empty D3 selection. And then we're going to run a transition for 1 second that every single tick will send in the current time, and that runs set degrees and rounds it to whatever the closest 360th is.
Yep.
Okay.
Yep.
So theoretically speaking, this should just start spinning in circles?
Yep.
Oh no. Let's see if we got an error. We did get an error. Okay, so we need a key.
Okay, that might be part of the problem.
That might be the problem, but let's see. I guess we can just like CX or how do I want to do this?
I think just maybe the what's it called? The scatter plots themselves also need a
key.
Yeah.
Okay, so for these ones, we can do like DX, DY. That should be random, or that should be unique enough. Let's see if that makes a difference. Encounter 2 children with this. Oh, come on.
Oh, I think we gave everyone the same index in the scatter plot, or the same key. Let's do what the chat is saying and use index as the key.
Use index as the key. Okay. Okay, so no more console errors, but we're definitely not getting spin.
What's missing? Let's see. Go back.
Thanks for your help, Tony. All right.
Let's see, what are we missing? So the rotation is there, degrees. Let's see if, let's try console logging the degrees and see if they're actually changing.
Yeah, I'm going to console log in here and make sure that it happens at all. Spinning, and we can do like T, and let's see what happens. T is not defined. That would make sense. So we'll set degrees. Okay, so it appears that it's not running at all.
Got it. Let me see. Is there something we have to do to actually trigger the animation? No, it should just.
Now, do we have to attach this this name?
No. Here's what we did wrong. It's not D3 select. It's D3 selection.
Selection. Okay.
Yeah.
There we go.
Why would they do that?
Oh, that's fun. Woo!
Nice. Now here's the cool part. You can add easing functions to this.
Okay.
So let's do after duration, type .ease.
.ease.
And let's do D3 ease bounce in out, or just bounce out. Ease bounce out.
Is that a function, or we're passing it in as the function it'll use?
we're passing it in as the function. So now they should bounce.
Holy buckets! Did that just work?
Yeah, so they go and then they bounce off the edge.
That's funny.
And let's add a delay as well,
Okay.
so that they don't start immediately. Do a dot delay, let's say 500.
This is great.
Add a delay 500 times math.random,
Oh,
because that's going to make it look more natural, because they're not all going to spin at the same time.
this is definitely the most useful data visualization I've ever created.
I know, right?
But what is cool about this though is like if we wanted to do so let's say we've got in our use effect we have, let's see, we're rotating through these, so let's pass in the index, and what we can do that'll be kind of fun
The other
here
one.
is we're going to get this index as part of our data point. So what I want to do, oh wait, this is the wrong one. So I'm going to take this and put it down here. And then we can do something like make these all come in at a slightly different time. So let's do 100 times the index. And so now what should happen is they should kind of go like in sequence. Oh, come on. Use effect.
Oh yeah, you're passing in index, not I. I think you called the attribute index when you were passing it in.
Oh, this is, yep, that's, so I'm not grabbing my index was the problem. So here.
You named the prop index, not I. So here you're using index equals I,
yeah.
But then in the actual function, you're doing I.
Index, and then down here we had index.
Yep.
And so now we've got each of our data points will be 100 milliseconds offset. And so if we were doing this like sequential data or something, and we wanted to do kind of like one of those wave effects where, you know, the first one moves a little bit and then the next one moves and the next one moves, we could kind of create that like, you know, like the wave in a crowd where everybody does their arms. We could do that with the data and give it this really nice loading effect, which would look super cool.
Yeah, I think so.
So while this example itself is very silly, the applications are really practical.
Yeah. And I like how with hooks, it's super easy to animate this stuff.
Yeah, absolutely. I was pleasantly surprised with how not painful that was.
Mm-hmm. And D3 transitions are actually smart enough to figure out if you have a slow computer or if you're loading a bunch of data and you start dropping frames, it's going to figure that out and automatically adjust so that you don't get, it's always going to take 1 second, even if it has to do it in just 2 frames. It's going to do the full circle in exactly 1 second.
That's slick. Well, cool. So, I mean, I feel like this was very successful and surprisingly efficient. We are we're roughly an hour in, and I feel like we've done a lot more than I would have expected me to be able to do with data visualization in an hour. Are there any other things that you want to show, or do you feel like this is a good place to call it?
I think this is a good place to call it. We've got this working. I'm super excited that it does static rendering, even if the axes don't show up. I'm really excited that actually worked.
Yeah, and with minor, so basically what we'd have to do is take React D3 Blackbox, and we'd have to create a React version that created those SVG components using React. So it's basically a matter of refactoring the Blackbox and not so much a limitation of D3.
Yeah, exactly.
That's pretty exciting.
I'm excited. This is really cool.
Yeah. Question in the chat from Mortal Draw. Could you use something like React Spring along with D3's animations?
I haven't tried, but I think you could, because I think at the end of the day, they both of these approaches depend on re-rendering your React component based on some sort of transition. So I think it should work.
Yeah, I can't think of any technical reason that wouldn't work.
Yeah.
But yeah, that's pretty exciting. I think I have another React animation event coming up here in a few weeks with Paul Henschel, I think his last name is. That's going to be more dedicated to like React animation. We also have Sarah Drasner coming on to teach us. Which one was it? Uh, is it Green Sock? What's the other one? There's Green Sock, and then there's the other really popular one. It's
There's so many.
whatever she used to do sarahdrasner.com or
Yes.
sarahdrasnerdesign.com. This really cool like animation here. She's going to
Yeah,
teach us how to use this
that's
stuff.
in 3D, right?
I think so. But she told me what the library was and I promptly forgot it. But so this will be super fun.
JS.
3JS, that's correct. Yeah, she's going to come on and teach us 3JS. So we've got a lot of really cool visual stuff. This is an area of JavaScript that I never get into, like data viz, animation, 3D. I've never done any of that stuff. We've also got Ken Wheeler coming on. I think he was talking about doing something with like Canvas and audio, which I'm already scared. It's going to be super fun. I saw him build an auto tuner with that a little while back. So, yeah, definitely worth. If you're into this stuff, we got a lot coming up on it. So subscribe to the Twitch so that you get notified and have all that access and good stuff. Swizz, man, this was super fun, and it was great having Kiwi on to provide the soundtrack.
Yeah.
Where should people find you online? So we've got your Twitter here. Let me post that in the chat.
Yeah, you can find me on my Twitter. I have my blog is at swizec.com. And for more data visualization stuff, I'm in the process of moving all of my DataViz articles to reactfordataviz.com.
Reactfordataviz.com, also going in the chat. So this is all super cool. Any parting words?
No, thanks for having me. This was a lot of fun, and I really like how you do your streams. I need to take cues.
Yeah, please steal this format. I've had so much fun doing it, and I'd love to be able to watch more people learning things in public. So yeah, Swizz, thanks so much, everybody. Thanks for watching. This will be posted on YouTube tomorrow. So with that being said, party on, y'all. We'll see you next time.
Yeah. Bye, guys.